Yeah, okay. So I'm very sure that it's pretty difficult to have a session just after lunch. So I know my work is very difficult, but I'll try so that you don't sleep during this session. All right, so because of time, I'll just go straight to the presentation. My name is Dr. Obadare Adewale. I'm from Lagos, Nigeria. I'm the Chief Visionary Officer at Digital Encode Limited. And well, arguably, I used to call myself arguably the most credentialized cybersecurity professional in Africa because as of present, I have over 56 professional certification, very active, that cut across governance, risk, and compliance. And I've been privileged to be doing PCI DSS pre-certification engagement in the last, I think since 2011, and I've been part of almost 200 PCI DSS assessment. So what I'm going to be sharing this afternoon is based on some of the things that I've seen, and I'm very glad about the previous session that we had before the launch, talking about how mobile is actually revolutionizing payments. And what we've seen, because over the time, we've seen a lot of vulnerabilities on web applications, and a lot of effort has been put in place to make sure that web applications are secured, right? So that's why we have standard like top 10 OAuths to make sure that web applications are very secure. But what I've seen, because now mobile is is revolutionizing payment. Now we have a lot of mobile apps, all over the place on App Store, on Play Store. How many of you have, maybe if you work in an organization that have a mobile app on a Play Store? Okay, so what I'm going to be doing this afternoon, just the same way, because most of the time we work with this illusion mindset that it's not possible for an attacker to actually compromise a mobile app because most of the time they're in an APK file, or if it is on Android platform, or also if it is on iOS, maybe an hyper files. But I want to show you this afternoon how we're going to be using combination of tools to make sure that you can do reverse engineer that particular APK file, and how, if you're not doing the right thing, it is possible for a cyber criminal to inject a malicious code. And so that's why the title of my presentation is Mobile Payment Reverse Engineering and Security Invasion. Of course, I've actually spoken about myself. So the objective is basically to see, we'll talk about the architecture, the different vulnerabilities and the threats that I've seen. And at the end of the day, the objective of this session is not to make the cyber criminals or the attacker a superpower. No. It's to see that how can you, at the end of the day, the PCI DSS standard, how can you make good use of it to build a good mobile app? Right. So, and of course, this is my starting thought. Like I said, mobile is revolutionized payment. Some futurologists and industry experts predict that in years to come, mobile phone will become remote controls for our whole lives. Everything, so it's going to be mobile everywhere. There is no doubt about that. But the truth of the matter, the truth of this is that, make no mistake about it, any platform can be digitally invaded. Any platform, whether it is operating system, whether it's web application, and the same thing goes for mobile applications. If there are issues with what I've called these 4 factors, and these 4 factors, we have the architecture. If the architecture is wrong, of course, an attacker can digitally invade a platform if the design is wrong, if implementation is wrong, and operation is wrong as well. Because most of the vulnerability that existed today were on mobile apps. Honestly, most vulnerabilities today is caused by what? Programming mistakes. And of course, sometimes you wonder, the developers, yes, why we have creative, hardworking programmers, but sometimes, with what I've seen, sometimes you see a lot of lousy programming out there. In fact, it seems to call it like irresponsible programming, because really, a lot of times, most of these 4 factors are not put in place to make sure that they develop a good software. So, and of course, for mobile apps, right, on all of these technologies, in Nigeria today, I'm very sure, of course, all over the world, we have the 5G, and I'm very sure, of course, all over the world, everybody, the mobile apps is riding on the 5G technology. And then, of course, mobile apps, just like, every other payment platform, you can actually experience all of these services on your mobile application in terms of your bill payment, fund transfer, utility payment, and in fact, interestingly, what is happening nowadays is most fintechs, most banks, from where I come from, are actually integrating the card, your debit card or your credit card with the mobile app, so that too for seamless payment situation. So now, but then, and you could have different architecture. You could have a direct architecture whereby, let's say, for instance, a bank owns the mobile app. So there are a lot of banks in Nigeria that actually have their mobile apps on the Play Store, on App Store as well. So that means the bank owns the mobile app. So which is what I've called the direct architecture. So what you see in that situation is you can see that the mobile banking server is interacting with the core banking application. Right. So that's one typical simple architecture that you could have. And then, of course, this could be another architecture that is like a third-party architecture. In that case, the mobile application is with a third party and is interacting with what? With the banking application, so you can have those two kind of infrastructure. Now, but then, with all of these beautiful use cases, and everywhere, all over the world, people use different platforms to build their mobile apps. You could have Flutter, you could have Reactive Native, and then, of course, Xamarin for Microsoft. So, different platforms have been used to build mobile platforms. Right. So, but whatever platform you have used, whether you have used Flutter, whether you have used Xamarin, whether you have used React Native, the reality is most of them, if you are practicing irresponsible programming, right, so to say, from my own language, honestly, you could solve out all of these vulnerabilities. So, but because of time, because a mobile app can actually be susceptible to both technical vulnerabilities and what I've called business logic vulnerabilities. And I'm going to quickly explain. The technical vulnerabilities are those well-known vulnerabilities like SQL injection, essentially what you have in top 10 OAups, cross-site scripting, and what have you. The same way a web application, it's susceptible to those kind of a technical attack, the same way a mobile app could be susceptible. But today, I'm going to be focusing on what I call business logic. Business logic means, because for every mobile app has a logic of operation, right? So every application, and especially here we're talking about mobile app. So today I'm going to be, looking at vulnerability like insecure validation, negative value injection. And what does that mean? It is very possible that if you're not doing what I've called, technically speaking, called server-side validation, it is very possible for a malicious person to actually download your mobile app, wherever platform it is, whether on the App Store or the Play Store, and use an emulator, right? So use an emulator, because most of the time you can actually use an emulator to simulate the mobile app on your laptop, and it works as if it is on your phone. So we're going to be seeing account swapping business logic vulnerabilities. What does that mean? It is possible that I can swap your card within the mobile app to your card. So I can, instead of paying myself, I swap your card, then I can take money from your card. We're going to see, because of not doing proper validation. And then, of course, there could be information disclosure, insecure, direct object reference, authentication bypass, based on what, because in fact, and these vulnerabilities, believe me sincerely, they are not theoretical. I remember just within a bank that when we explained this to one of the bank's mobile app that we tested with my Tiger team recently, and they were making a lot of argument. Developers, they like to defend themselves because they're like, what do you mean? We're programmers. We know you don't, what, So, but then we said, see, calm down. There's no point for argument. You know what? Do you know what we did for the guy? We just asked him for his account number. And in the process, we actually used his account number to do your account swapping. Guess what? He got a debit alert. And he was shocked. In fact, when we got to the contact center of the bank to say, okay, let them explain, because from the transaction history to say what has gone wrong, they could see that he was the one that transferred the money to our own card. He was shocked himself. So, and we're going to be doing all of that. So, but then how do you do all of these things? Because there's no time, I actually wanted to, so what I've done is in my lab, because time is finite, is to do a pre-recorded video so that we can see, but what are those tools that most of these guys are using? One of them is Nox. Nox is a mobile application emulator, and then there is BobSuit. The BobSuit is a global interceptor. You know, what I mean global interceptor is you use Nox to actually emulate and simulate the mobile app on your laptop as if, it's working on your phone. I mean, the mobile app as if it's working on your phone, and then you have the BobSuit that intercept. Just like you can have, how many of us remember the man-in-the-middle attack at the network layer, where you can use tools like Cain and Abel, Ethercap, or Subterfuge. The same way, you could actually simulate what is called a man-in-the-middle attack at the application layer. Because if you go back to the fundamentals of TCP/IP, OSI layer, you have the application layer, of course, we have the network layer. So you can actually do an interception using BobSuit, and then you can use a tool. The JDX is used to reverse engineer the APK file or the IPA files. What does that mean? If you are not doing code obfuscation, right? If you're a programmer, you know what code obfuscation is. That's why it helps the attackers to find it difficult to read the codes. But most of the time, they don't do it. And because most of most of us are business people, we don't even understand all these technical details. There is no time. So what I'm going to do is I'm going to use a combination of all of these tools, and I would like the studio to play the video one for account swapping. If I can have my video. Yes, so now, look at this very well. And in fact, interestingly, please pause, please. Can you pause? Okay. If you notice, that's the beginning of the video. It's WATF. Do you know what that means? It's what a terrible failure mobile app. So easy. That's what it means. So this is a sample mobile app. It's available on the internet. You can actually look for it. And that actually explains what most of our developers are doing. But I won't totally blame them. I will blame because most of the time, when we say we should train our programmers on secure coding, most of the time we struggle with, oh no, they are programmers, they don't need to be trained in secure coding. But believe me, based on PCI DSS requirement 6, this is very important. Now, look at this very well. You can see WATL, what a terrible failure mobile application. So now, this is like the attacker, name, IMA. Look at that account number like your card number, your primary account number. And then, so play, please, studio. Can you play? Now, just watch this very well. Look at the 333 is just like, don't forget, this is a demo. And look at the balance. Look at the balance. And now, I want to do a transfer. And what I'm going to do is, to substitute another card number, which is 44444, right? And then with a figure of 5,000. So now, because I've set this up in my lab, so the global interceptor, which is the BobSuit. Now, pause, please. Pause. Can you pause? Now, this is the tricky part. Now, if you look at this, now there's usually a what? A response, a request from the client and a response from the server. What the global interceptor does, and believe me, most of these bad guys can do this from the comfort of their home. So what it does is to break down the communication. That's what BobSuit sought. The tools is free on the internet. Of course, you can buy a licensed version of it, but most of those guys, the criminals, don't pay for the licensed version. So they have this tool, and guess what? They could see the response from the client and what? The response from the server. And what they could do, because now, there is not, don't forget, there is, when requirement 3 in PCI DSS say there should be encryption. And when you're talking about encryption, you talk about encryption, data at rest, data in use, and data in motion. Most of the time, people don't pay attention to most of those requirements. And what do you see? Because there is no encryption, it was actually very possible to see everything in clear text and then play, please. You can see. So now what I'm going to do is to swap those details from, So what happened was that was fast, is to say, okay. So what happened was So now the transfer was done. But what happened was I actually swapped like your card to my card. So when you're going to see a debit alert, I'm not going to be debited, but you are going to be, debited because why? What is happening on that mobile app is what is because there is lack of server-side validation. They were doing client-side validation because normally, even if this interception is going to happen, what should have happened is that there's going to be a server response to say, no, you cannot have, you can't have the same, you cannot swap this, and it should just truncate the transaction. But because server-side validation wasn't done, that was why this was possible. Can I have the other video, the second video for negative? So now watch this also. So just pretty the same way, you can see using the same mobile app because the vulnerability is within the system. So from your card, so what can happen is to use a negative integer. This is like your manufacturing money. Yes. So it's to use a negative integer and just debit the system because just watch this. So that's like a typical card number, so to say. Then I'm trying to transfer 5,000 because that's the way the process flow for the application. So I put $5,000, right? And let's see. Okay, change it to $7,000. Let's see and say transfer. Don't forget, because this is in clear test again. So what I'm going to do right now is just watch this properly. Look at that's my card number. Then I just change it and then go back to the figure so that I can get the transfer. Now, look at the $7,000. Just watch properly. I put a negative integer. Technically speaking, this is possible, but the concept of accounting is for every credit, there must be a corresponding what? Debit. But believe me sincerely, if this kind of vulnerability exists within your mobile app, every credit is like, it works on logic. That's why it's business logic. So, because minus plus minus is what? Minus minus is what? It's plus. So, but what the root cause is because why? They weren't doing what? Input validation. Because if there is input validation, it should say, no, you can't use the negative integer. This is programming 101. You understand? So, because there's no time, please can I have my slide back? But what am I trying to say this afternoon is, what we can do, if I've had time, believe me sincerely, there's a lot to say, but the reality is, if you look at the requirement of PCI DSS properly, especially requirement 3, requirement 4, and then most especially requirement 6 on application development, because it starts from saying, do you have a software development life cycles? In fact, I've interacted with a lot of programmers, and I find that most of them, while they are good programmers, but most of them lack the security experience. They could code. You understand? So my point this afternoon, because of time, is to make sure that, because if you look at, because of time, I would just say, of course, encryption is very important, but don't focus only on encryption on network layer alone. You should also do encryption at the application layer. That is very important. And then, of course, the requirement 4 talks about the transmission encryption. And then, of course, requirement 6 talking about processes for ensuring that those 4 factors, architecture, design, implementation, and operation, for you to be able to do them well, you need to look at what the requirement 6 and find a way to make sure within your team, before you go live on your mobile app, you make sure, right, that everything that you're doing, because one tricky thing about mobile app is, if I use a JDX reverse engineering tool, because today, Play Store don't validate if I try to mimic your mobile app and put it on Play Store. It's only on App Store that goes through rigorous process of validating who owns this mobile app and issues an application ID. But unfortunately on Play Store, so they don't. So the responsibility lies on every organization, and saying that, and you have a good tools with you, which is the PCI DSS standard. If it is implemented very correctly, making sure that you are using it to change the culture of your institution because there's this unending argument about compliance and security. Most of the time, I don't think we should even engage in such unending argument about, PCI DSS is for compliance, is not achieving security. I have a very different mindset because the truth is it's about asking yourself, do you want to breathe in and breathe out? You understand? You need both. You need compliance requirement like PCI DSS to build a good culture of security. And I think PCI DSS, if you look at all the details, can help you to achieve that and build a well-defined secure mobile applications. Thank you very much for listening.